The next section that we want to cover is significant figures. So this is going to be a very important concept as well, because it's going to indicate how well you can measure a natural phenomena. So the number of significant figures in your measurement is directly correlated with the equipment that you're using in the lab. So with any piece of equipment, you're going to be limited to how far out you can take that data. And so when we're looking at significant figures, you want to go out to the position where you have to make a guess. And so the last position of any number that you see within the literature is going to be the guess position, or where that scientist had to guess at the number. So if we were looking at this graduated cylinder and reading the volume off here, we read from the bottom of the meniscus, so you can see that this is actually sloped downward towards the center. So this is where we would want to make our measurement reading, not out here at the edges. And when we do this, we're seeing, okay, we've got increments of 1 milliliter as we're going up here. So we've got 15, 16, 17, 18, 19, and 20 would be here. So we can accurately measure that we've got 15, 16, 17, and somewhere between 17 and 18, this measurement is going to lie. So since we have no more grades inside here and we have no more units that we can measure, we have to make our best guess in between 17 and 18. So this position here will be our last significant figure that we can make for this reading, and this is going to be the place where we have to guess. So if we're guessing here, we'll go up 15, 16, 17. I'm going to say that this is about 17.6 is where I would read this. And you could say it's 17.5, you could say it's 17.7. So this is where you've got your best guess. And so as a scientific researcher, you make your best guess and you place it in here. So this is the number of meaningful digits then that are used to express a value. And so we couldn't go out and say this is 17.65. Adding that extra digit in there, that 5, would be ridiculous in this case, because we can't even make out whether it's going to be a 6 or not. So we can only go out to the first place where we have to guess in any of our measurements. And so that's why we have to use significant figures. And we have some rules when we're utilizing significant figures that we're going to go over. So to indicate the precision of measurement then, the value recorded should use all the digits with known certainty plus the one estimated digit. So this is your guess position. So no further insignificant digits should be recorded past the first guess. So our total number of digits that's used to express such a measurement is called the number of significant figures. So all but one of the significant figures then is known with certainty, and then the last significant figure is the best possible estimate or the best possible guess for that figure. So below we have two measurements of the mass of the same object, and so the same quantity is being described at two different levels of precision or certainty. Even our balances within the lab, that last position that they give you as a reading is the estimated position. It's the guess that the balance is making, because that's the accuracy on the balance. And so you can have different balances that will go out to different positions of certainty. So in the first balance, it only goes out to 2 places past the decimal. So what this is telling you is if we have a reading of 54.07, that the accuracy around this position is in question. And so this is telling you that the mass is somewhere between 54.06 and 54.08, and that the best guess is plus or minus 0.01 grams. So it's going to vary around that position. If we have a balance that has higher certainty and can go out farther places, so we get an estimate of 54.07138, this uncertain digit here is this last position here, and this is telling you then that the mass is between 54.07137 and 54.07139. So it's plus or minus 0.00001 grams around this estimated position. So that's our uncertain digit. So that's really what the uncertainty means when you write out your significant figures. So when we calculate things on your calculator, you're going to notice that it's going to give you a long string of numbers. And so you have to be able to choose where your significance is going to be at in your calculated figures. And you're going to have to round your numbers to achieve the correct number of significant figures for the measurements that you've made, because you can't go past your uncertain digits in any scientific measurement. It would be a misrepresentation of your data. So here's our rules for our significant figures. Rule number 1, zeros in the middle of the number are like any other digit. They're always going to be significant. So trapped zeros are significant. Zeros at the beginning of a number are not significant. They only act to locate the decimal point. Zeros at the end of a number and after the decimal point are significant. It's assumed that the zeros would not be shown unless they are significant. However, zeros at the end of a number but before the implied decimal point may or may not be significant. You can't tell just based on the number itself. So let's look at some examples of these. So if we have 1004 written down, how many significant figures do we have? Hopefully you guys said that there were 4. These zeros are trapped in between the numbers, and so they are going to be like any other number. They will be considered significant. So 1, 2, 3, 4. These are trapped. They're significant. We've got 4 significant figures in this number. How about this one? So if you've got zeros on the right side of the decimal place, these are going to be significant because they would not be shown unless they have significance. So trailing zeros to the right of the decimal place are significant. So this one has 1, 2, 3, 4, 5 significant figures. How about this one? 54,500. Are these zeros significant? We can't tell just based on this number alone. So we know for sure that there's 3 significant figures in here. 1, 2, and 3. These are significant for sure. These can be placeholders. We don't know if they're significant or not. They could be significant, but they might not be. The researcher would have to tell you if these 2 zeros are significant or not. So we definitely have 3. But we could have 4, or we could have 5 significant figures in this number. We can't tell just by looking at it. How about these zeros in front of this number? Are they significant? No, they are to the left. They're just placed in here as placeholders. So this number would only have 1, 2, 3, 4 significant figures. How about these guys? These guys are also not significant. They are only placeholders. To the right of the decimal but before the number are not significant. So if you have leading zeros that are to the right of the decimal place but to the left of the main number, they are also not significant. They are only in here as placeholders. So in this one, we've got 3 significant figures. So when you're making measurements in significant figures, some numbers are exact and effectively have unlimited numbers of significant figures. So all of our conversion factors, for example, are exact figures, and so you don't have to take into account the significant figures in those conversion factors. You only have to take into account the significant figures that are in your measurement values. So there are other numbers that have exact numbers as well. So our class, for example, will have an exact number of students. We can only maybe have 32 students. You can't have 31.9 or 32.1 students. So some things are all or nothing. And so again, our conversion factors are defined units. So 1 foot has exactly 12 inches in it. So anytime you're using conversion factors, you don't need to worry about the significant figures in there. They're exact. And we'll see when we get to adding, subtracting, and multiplying and division how we actually are going to round up our numbers and to maintain our significant figures. But that'll be in the next section.